In this video, I'll be working through the question you see on the screen from the Mechanics paper 4.2 from the Cambridge A-level exams from 2023. I'll be doing this on the board, hopefully just like you're used to your teacher doing in a classroom. If you want any other questions from this paper, you should be able to find a link to the playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate if you subscribe, or if you think any of your friends might find it useful, please go ahead and share it. In question 7, they give us a diagram, roughly what you see on the board here, with a lot of English, a lot of numbers and words trying to explain the system. I'll try and explain it in my own words right now. We have a pulley system with two weights. This weight is hanging down and it's only 0.25 kilograms. This weight's a lot heavier, it's 2 kilos, but it's on a flat surface and they let go of both of them. Now, sometimes they might ask you what happens. They don't really care, at least do they say it or do they just imply it? It implies that it will fall down the hill. It'll go from A to B to C, because they ask us questions about that. It makes sense really, this is a fairly heavy weight, even though it's on only a 30-degree angle. So this will start falling down the hill and this will come up with it. These two, the tension will always be okay. The string is magic. It's not going to stretch or unstretch, not like a real string. The pulley, again, it's perfect. There's no friction. There's no heat in there. Again, not like real life, but very common for these maths questions. What else? They tell us this has friction. The coefficient of friction is 0.3. So it's rough, they tell us here. That's normal. This one is magic again, there's no friction. B to C is just perfectly smooth. Makes it a bit more interesting. And I think that's it. That's pretty much all the info we need about this. Oh, we have some distances, 0.8, 1.2. And then to put our mind at ease, they say, don't worry about this hitting the pulley. There's plenty of room for this to get to here, okay? And that's it. And then they ask us their first question, A part 1. Find the acceleration between A and B. Now, I think we can use energy to do this. I won't do it. If enough people want me to do this whole question using energies, please put them in comments. I'll see, or maybe I'll just write out a answer in the comments. But yeah, that's one way to do it. I'm going to skip that. I think, yeah, the marking scheme does give some answers for that method. So apologies if that's what you came looking for. I think it's much more common to do how I'm going to do it. Another way I see to answer this is, I often answer these questions using a little cheat. I often ignore the tension in the string that we're going to find in these questions. And I can do that because this is such a magic system. The tension is perfect, the pulley doesn't lose anything. I'll treat this as one whole object. I'm not going to teach it though, because I think it causes some bad habits doing it that way. It does make it a little simpler, but I won't teach that way. How I'm going to teach this is, I'm going to look at all the forces acting on this guy here. And they must add up to a total force, force F equals ma. And I know what the m is for this mass here. And therefore, when I add up all the forces, I should be able to find A, the overall acceleration. Because remember, if he's coming down this way, he's going up this way. And the acceleration of this guy is the same as the acceleration of this guy. And that's what I'm going to do the same up here. I'm going to add up all the forces on this object. And their answer must equal ma. This is a different m. So this guy's force will be 2a, overall force. This guy overall force will be 0.25 times a. So that's what we'll do, and that should find a with not too much work. So let me write that again down here. This guy, the forces on him will be force from the weight, from the mass. That's its mass times gravity. 0.25 times 10, which is 2.5 newtons. I won't put in all my units until the end, so apologies if I miss some units. 2.5 newtons down, And going up, we'll have tension, T newtons. The tension going up. And this one over here, oh well, let me put both the force diagrams in first. This guy over here will have a force going down of 2 times 10, 20 newtons. It's a rough surface, so friction will be involved. We'll have a friction force. Obviously that friction force is based on its reaction force. Again, because there's a weight coming down, there must be something, we must be pushing against the ramp. So that means the ramp must push back. That's where we get the reaction force. And what else? Oh, tension. I'm missing tension. That's in here as well. Same direction as the force. T. Again, add all these up, at least in the direction of acceleration, and we should equal 2a. So that's what we're going to do here. This one's very simple first. The direction is going up, so T will be positive. T minus 2.5. That must all add up to F. F equals ma. That must add up to 0.25 times a. And a is what we're looking for, so it's a good thing that's in our equations. And we do the same for this guy. The only thing is we need to move everybody into, let's draw it again. Force can stay that way, tension can stay that way, F, T. We need to change this guy into this direction here. So we need his component going into this way. So you'll have to work out where the angles are. Remember, this angle down here is 30. This angle in here is 30. That's 90. So that'll be 60. So this angle in here will be 30. So we'll be left with a triangle. Let me draw that triangle in there again. So this guy's 20 down, right angle there. So we're looking for this length, the length in the direction we're interested. And with a bit of geometry, we know that'd be 30. So the opposite the angle would be the sine. So this guy here would be 20 sine 30. And or doesn't matter. Or's out this way. Don't care. The component of gravity down this way and or this way, I just don't care. They're not in the direction. They're perpendicular to my acceleration. So I really don't care. I happen to know they'll add up to 0 because otherwise the ball would jump into the air or sink into the ground. So they must add up to 0. Which I guess, actually no, that will matter. I do care a little because I need to know what or is. So or will equal to this guy, we'll add up to 0. Anyway, for this equation, I'm ignoring these two. So let's see, we're going this direction. So we'll have 20 sine 30. Sine 30 is just a half. I'll deal with that in a moment. Minus T, minus F. And all this must add up to mass times acceleration, 2a. We get two equations, simultaneous equations. We just have to solve it, except there's a problem. T, A, F. We've 3 unknowns, can't do it. So we need something else. And sorry, we did use these two ideas here. So what this component would be 20 cosine, cosine 30. Because we need this because F is equal to mu or F is equal to 0.3. That was the coefficient here, 0.3 or. So we need to try and find F. So we need to find or. And like I just said, or has to equal, these two have to equal 0. So or must equal this guy. So F must equal 0.3 times 20 times cosine 30. We can put all that into a calculator and let me just check. We get 3 square root of 3. That's cosine 30 is square root of 3 over 2, I think. This is 6, 2 divided by 6 is 3, square root of 3, yeah. So we know what F is. We can write these two, actually, let me not bother write these two again. You guys can pause and look back. I'll just save myself some space. We'll just rub out F and put in 3 square root 3. Again, if you want to see what I wrote there again, just rewind, pause, use the magic of YouTube. Now we just have a simultaneous equation, T's and A's. Very easy to solve, especially because the T's match. They cancel out. That's sort of what I was talking about at the start, when I sometimes use a method that just ignores the T's. And we find we can ignore the T's quite easily when they're a perfect pulley and stuff like that. And the tension of the string is, again, perfect. So we just add these together, add the left side to the left side, the T's will cancel. So let's see, we get to, let's fix this now. Sine 30 is a half. Put this in a calculator. 20 sine 30, you'll get 10. Minus 2.5. And minus 3 square root of 3. Almost equal. The two right sides added would be 2.25 times A. Again, let's divide both sides by 2.25. 2.25, 2.25 cancels. Put this in a calculator and we get A is equal to 1.02. What's yeah, let's get a few more digits. I never mentioned the exam makes, I will call it a mistake in their marking scheme, in that they use this number for the rest of the question. We're going to have to use A for the rest of the question, but this number is not perfect. It's close, but that's a little closer. That's not perfect either. But I like to take five decimal places, or sorry, 5 significant figures for use in the rest of the question. Now for their answer for this, so I'd write this down somewhere for myself. Let's put it up here. A is equal 1.0239. So for the rest of the question, which I happen to know we're going to need it, I would use a better number than the marking scheme used. Because the marking scheme just goes ahead and uses this number, which is the correct answer to part A part 1, meters per second squared. That's they want for your final answer. Round off to 3 significant figures, but if you're going to use that for the rest of the question, personally I like to use a few more, because if you get 2 numbers that are slightly wrong, they can add together to get one that's very wrong. It rarely happens in the exam. I don't think it happens in this question. I think the final answer in this question is fine whether you use this number or this number. But the marking scheme, some of the middle bits of the marking scheme have different numbers than I got, because I used just the more accurate ones. So I just a bit of a warning there. Okay, so that's A part 1. We'll keep this number up here, like I said. I'll clean this off and we'll do A part 2. Okay, A part 2 is, I would say, quite a hard question, and it's one that takes a lot of students by surprise, because it's just a really short question. It's find the speed of P at C. Usually when they ask something like that, let me tell you what they would usually have asked in an exam. They would have asked find A between A and B. They did that. Then usually they would ask something like find A between B and C. Or they would say find the speed at point B. And then finally they would say find the speed at part C. They've left out all those middle parts. They've just asked you to find the speed at part C. Now the reward for that is 5 points. So this is a big question. This is a lot of marks for this question. You have to take some of those middle steps yourself. You can do them in many different orders, and you can in fact do them in a couple of different ways. I'll show you the main way I'll answer this question is I'll use the equations of motion. You know, V is equal, like initial speed, final speed, acceleration, time, and displacement. That's how I will show you. How I personally would do it is I would use A is equal 1.029, then I would integrate to get V. V is 1.0239 t plus initial speed, which is 0, and S is equal 1.0239 over 2 t squared plus the initial displacement, which I will put in as 0. That's how I would answer this question. And I would use these three equations, I would solve everything, and then and this is between A and B. And then I'd do the same between B and C. I would need to find A just like we did in part 1, and I would use those three equations. That's personally how I do it. As it happens, this will help this question because part B, they do want to find T. So my way would help, but it's not the most common way students would do. Mostly students would use the equations of motions, which I'll put up on the board there, or at least on the screen. And that's like A. Well, let's split into this world first. A to B. A to B here. The acceleration is this. The initial speed is 0. The final speed, we don't know, but that's something I'd like to know. T, we don't know. We don't need to know for this part. Again, part B we will, and it will become useful, but don't really need to know. And then displacement S, and we do know that 0.8. Sorry, I haven't said why I would need V. We're looking for V at point C. So let's do that. Let's give it a bit of room here. Let's do that over here. B to C. We need V. We want to find V at B, at C. So we need the initial speed. Don't know it, but that will be here. So that's why I want to find it. I'm skipping ahead. We might need A. Don't know it. Might need S. We know that, 1.2. Maybe we need T. Don't know it. So we're missing a lot. If you want to find what V is in this world, we're missing a lot. So one thing, I can find V quite easily by doing this. And then, as it turns out, we're going to have to, I'll do that up here, I think. Hopefully I'll have room. We're going to have to find A. In fact, I'm not going to have room, so I better be a little careful. We're going to need to find A for this world. So this would be a bit of a plan I try from the very beginning. Like I'd be just thinking, I'd be making guesses, to be honest. What do I need? How do I get to V? I'd be jumping around things like this. But the clear path I now see is I would use the equations of motion to find V. To find V, then I would need U. To find U, I need to find V in this world. And that I can do. Okay, boom, I can do that. Let's actually do that right now. What uses all of these? The equation phi squared equals U squared plus 2AS. Phi squared is equal 0. 2 times A, so 1.0239 times S, 0.8, and then V is equal to all of this, the square root of all of this, 39, 0.8, square root of all that. And that answer is 1.2775. So I can now put that in over here, 1.2775. I'm still missing stuff over here. So I'll have to bite the bullet and find one of them. And the thing is, in the previous part, part 1, we found the acceleration between these two guys. So we should be able to find the acceleration between B and C. Let me just spell it out up here, and I'll probably do the maths down here. I do it the same way as I did part 1. 2.5 newtons down, T newtons up. This guy over here has 20 newtons down, has a reaction force, or has tension, T, but it no longer has friction. Friction doesn't come into it. That means I can take the component of this guy, just like previously it was 20 sine 30, and well, I don't care about it this time. It doesn't matter because these two are quite simple. Now let's do it out down here, and then maybe I'll rub it out. Maybe I might have room to do it up here. So I'll do the answer to this down here. This is t minus 2.5. This is this world. T minus 2.5 must equal 0.25a. This guy here, 20 sine 30 again is just 10 minus t must equal 2a. Much simpler, no f's involved. So if there's no f, I don't need to find or. I can just add this together. I get, on this side I get 7.5. On this side I get 2.25a. A is equal to 7.5 over 2.25, which is equal to 10 over 3. 10 over 3. So I can go ahead and put that in there, 10 over 3. That's enough now to answer this question. Hopefully you're following along these steps. They are multiple steps just to find the speed here. That's, again, this is why we're getting 5 marks. There is an equation, the same equation I used here. It doesn't need t. The same equation, phi squared is equal to u squared. I don't have room to fill it in, but this number squared plus 2 times this number multiplied by this number. I can fill all that in. Let's have, I got it written there somewhere. Let's just do it in the calculator right now. 1.2775 squared plus 2 times 10 over 3 multiplied by 1.2. So I get phi squared is equal to 9.632006. Get the square root of that, that's phi squared. Phi is equal to the square root of all this, and that is just 3.1035. Yeah, that'll be enough. They wanted, this is the answer they wanted. So let's round it off. Phi is equal 3 significant figures is 10. Don't need to write 0, so meters per second. That's the answer they wanted for this part. Yeah, there was a lot of steps to get to that. Like I said, personally, I wouldn't have used these formulas. I would use integration to get more general formulas. It wouldn't have made it any easier. I still would have need to find a using this method. The only thing I like about my way is, firstly, I don't have to memorize these equations. That's what I like, and it actually does. It makes it easier to answer the next part, part B. But we'll do part B without the knowledge you would have had from the integration I put up. We'll just use what we have on the board here. Okay, let me clean some of this off and we'll do part B. Okay, for part B, it simply asks to find the time taken from A to C. Again, one more time, I will point out, it's 4 marks for this question, so it's a big question. I will point out, if you had done the previous part using integration, acceleration, velocity, displacement, we would have already found the t, and this question would be finished. So I will say that, but if you're doing it the way I think most students would do it, what we're now looking for is the time it takes from A to B and the time it takes from B to C. And the advantage is this isn't actually too hard either, because we have a lot of the work done. And we have all of these numbers from the equations of motion. We just need to find t, add them together, and we're finished. So let's throw up our equations of motion again. Which one of these work for that? I think we have a couple of choices, but the main one I would use is phi is equal to u plus at. Let's see, we have v, we have a u, we have an a, and we want the t. And again over here we have a v, we have a u, we have an a, and we want the t. These work for both of them. So let's just find the t for this one, and then we'll do it for this one. Let's see, it's 1.2775 is equal to 0 plus 1.0239 times t. We just clean all this up, that disappears, divide both sides by that. We get 1.2775 divided by 1.0239 0239 equals t. We put that into a calculator, 1.2775 divided by 1.0239, and we get t is equal 1.247, let's say 7. Now I think this is where the answer in the exam, I think they might get something different here. Oh, you know what? No, I think they get the same answer for this part, or roughly. They rounded off to 1.25. It's the answer here that the answer in the exam, in the marking scheme, is wrong to 3 significant figures. But once you add it to this, it's fine. Anyway, that's t. That's 1.2477. Again, my motto is that never round off. Certainly never round off to 3 significant figures unless you're finished, unless you're at the answer. So we do the same thing with these guys. Same world here. V is 3.1035 is equal 1.2775 plus acceleration 10/3 times t. Clean this up, we get 3.1035 minus 1.2775 divided by 10/3, which is just like multiplying by 3/10. All that equals t. Put all of that into a calculator, and I don't think I have that written down, so I better do it now. 3.10 minus 1.2775. Let's see, multiply by 3, divided by 10, and we get 0.5478. That's the answer. It's actually different in the marking scheme. They get a different number than this, and that's just because they rounded off these numbers and the 2 mistakes added together a bit. Again, it won't matter. You'll see in a moment it won't matter. 0.5478. The answer they're looking for is these 2 numbers added together. So the final answer t is equal 0.5478 plus 1.2477, and that is equal to 1.7955. But they wanted the 3 significant figures, so that's 1.80 or 1.8 seconds. That's the final answer for that question. Let me just check. Yeah, 1.8. That's the final answer. 1.8 seconds to get all the way from A to C. All right, that was a difficult question because they didn't hold your hand. They didn't step you from, pardon the pun, but A, B, and C. They didn't step you from one part of the question to the next part. They often do that. In some questions in the exam, they will do that. Others they won't. That's how you get your. That's how you change between a B and an A. Really, if you're a B student can get all the parts where they help you, but they fall apart a little when they're not helped. An A student should be able to do it all. That's how I see the real difference, at least. Okay, that was a big question. Lots of numbers on the board. I'm bound to have made a mistake. If you've seen a mistake, let me know in the comments. If you have any follow-up questions, let me know. I'll do my best to answer. And thanks for watching and have a great day.